Hello everyone and welcome to today's workshop. So we will have the second day of this WEkEO for forest monitoring. So this is a Copernicus WEkEO service workshop and today we will have the practical session. So as you know, 2 days ago we gave you an introduction to the Copernicus WEkEO service and what sort of data you can find, and we also provided some example on how you can use the data for forest monitoring. So today we will have a more practical session. So we will show you how you can visualize the dataset and how you can apply it to a case study. But before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible way. So first, don't forget to join the audio on the left bottom side and do not use the chat that you see on your right side to ask questions. You can use it for small talk or talk between each other, but if you have a more technical question or any other type of question, you can use the Q&A section on the website that you see here. So it's on the top bar of your page and you will find the Q&A button. And yeah, that's where you can ask the questions to the speakers of today. So speaking of our speakers, we will have 3 interesting tutorials and 1 demonstration. So we will start with the WEkEO viewer demonstration by Alexandre from Mercator Ocean International. And then we will have a Jupyter Notebook tutorial presentation by Alvaro from Now Systems, a QGIS tutorial presentation by Stefania, also from Now Systems. And finally, we will end with the RStudio tutorial, also made by Alvaro here. So today, as I said, it's a practical session, so you might have already explored all of the materials we made available for you on the website and the specific exercises that were developed for the topic we will present to you today. So as you can see, it's on the top bar, you have Jupyter, QGIS, and RStudio. And as you know, today will be a summary presentation of the tutorial, and you can also ask your question there. Okay, so we will start with Alexandre demonstration. So whenever you want, the floor is yours.
Yeah, thank you. So let me share my screen. All right. So is everything good?
Yes, you're in full screen.
Okay, thank you. So hello everyone. I'm Alexandre from the WEkEO user support, and today we will talk about the WEkEO viewer. We will see how to search for the data we are interested in. We will see how to visualize and download data, and we will see the tools and the interface to familiarize yourself with the WEkEO data viewer. So let's meet on the WEkEO homepage that you can find at the URL wekeo.eu. First, let me show you how to register. You can create a WEkEO account for free, and this allows you to download and use our tools to download and see data. So to register, you have this button on the homepage where you can click on it, and then you will have to fill in this form. So it's free, just remember. So let's now meet on the WEkEO data viewer. For this, you will have to click on data. There, if it's the first time you meet this page, you will have 2-layer display by default, like this. To access the WEkEO catalog, you can click on the plus button next to layers. There you have our catalog. On the right, you have more than 400 datasets available. You can see that some of them can be displayed on the map with if you see this eye icon, and other can be displayed. This is the number of layers that you can display from this dataset. On the left, you have the filters. You have the search box where you can find with some keywords or the dataset ID, the name of the dataset. Then you have filters like the Copernicus service, the platform, the area, many tags. For today, we will choose a CLMS land dataset with the tag vegetation. So now we have left 8 datasets. Today we will choose this one, the season minimum value 2017 to present, which is available display only data in Europe, and which is a yearly dataset. On the left, you have the thumbnail, where you can see where data will be displayed. And then you have a quick description of the dataset. You can add this dataset to your favorites. And today we will display the details. So there you have sometimes it's not for all datasets, but a use case. You can click on it to show what we can do with dataset like this. Then you have the thumbnail, the temporal extent from January 1st, 2017 to now, the latitude and longitude extend, the button to add to map the dataset, an abstract with many information about the dataset, the dataset ID, which can be useful if you use our HDA to download data via script, but it also can be useful if you want to share with us, the WEkEO support, with which dataset you're using. So it's a common way to name the dataset you're using. Then you have the Copernicus service, the area, time, other information, and metadata. So today we will add to map this dataset, and here we have all the layers we can display on the map. Today we choose the total productivity season 1. So we click on add to map. Then we can close this window by clicking on the cross or outside the window. And there we have our layer, total productivity season 1. We have the date of the data display on the map, the area, the color map, and some buttons that we'll detail right after. You can hide the layer on the map. So I will hide the 2 default layers. Then you can zoom in and zoom out with the scroll of your mouse. At the bottom, you have a timescale where you can choose the date of the data display on the map. So now it's 2023, but if I want 2020, I can click here and the data will update on the map. So I can change 2022. Let me show you just that there is also a depth scale for dataset of the water. If you want to display only data at the depth of, for example, 4,000, you have this time scale to adapt the depth. So let's hide this dataset. At the bottom right, you have tools. The first one is the locate tool to draw a point on the map. This will allow you to get the coordinate of this point. Then you have the measure tool to calculate the distance between few points. Quick tip, you can exit the tools by pressing escape from your keyboard like this. And then the most important is the set area of interest. This allows you to draw a bounding box on the map like this. This will be useful if you want to download only data in this bounding box. We will see how to use this bounding box in the subset button. So just keep in mind. And then the settings button to parameter the viewer. So we can decide to show or not the base map, show or not the coastline and reference features. We can change units from kilometers to miles or other units. And then we have the credits. Now let's talk about the buttons. So the first one is the subset and alert button that I will detail just after. The information button to come back to this page where we have all the details of the dataset. Then we have the layer button to change the layer we want to display before we choose the total productivity. And if we want to change, we can do this here. And then the setting button to change the opacity of the layer. This can be useful if you want to compare, for example, two layers at the same time in the same area. You can decrease the opacity and yeah, display two layers at the same time. And you can change the color map if you want something with more contrast. Let's do this. So let's put it by default again. And then the subset enrolled button. So to use it, you will have to connect to your WEkEO account. If you don't have one, you can create an account. You just have to fill in the form, and this is free, and this will allow you to download your data. So let me sign in to my account. Up. So there we have all the variables, all the fields to subset our data to request results we want. So all the fields are not mandatory. You can see mandatory fields with a red asterisk. If I want to show you here, like these variables have a red asterisk for the dataset seawater salinity. So here you will have to select the variables, but for our dataset, none of them are mandatory. So today we will choose to download only the year 2023. So I can click on start date to choose a date. So I'm going to 2023, 1st January, like this. But you can also enter the date manually. So like this. I will put 2024 to be sure. And you can also copy the date from the timescale. For example, if I'm going to 2021 and then copy from layer, the date will change like this. So let's go back on 2023. And then we will subset according to the bounding box. So I drew this bounding box before, so I can copy my area of interest from the map by clicking on this button. There we have all the coordinates matching this bounding box. And you can also enter the coordinates manually. Depends on what you need. So this will limit the data to this bounding box. Some datasets can be downloaded by tile. So sometimes a tile can be outside, give you data outside the bounding box because the tile is not completely included in the bounding box. So keep in mind that sometimes you can have data outside the bounding box, but that doesn't mean that you don't subset according to your bounding box. So on the left, you have the show API request. This is the API request that can be used with the harmonized data access HDA API. This can be useful if you want to download data via script. The HDA API is available via Python, but also with R and with curse commands. With the viewer, you have this request that you can copy, and I recommend to use the viewer to get the query with the right formats and with the right format and all the variables with the right name according to what the dataset proposes. I know that sometimes the format can change due to updates. So I recommend to go through the viewer to get the right request. And then we will request the data. So at the bottom right, you can see that the request sent successfully. To show this request, you can click on the Jobs tab here. And here we have all the requests we have made with an historic. So you have the name of the layer, the date at which I made this request with the time, the status of the request, which is now completed. We have this button to show the API requests we see before, and the folder button to see all the results. So for this request, we have more than 50 results. We can see them here, and for each of them, we can order them. This can take some seconds, sometimes minutes, depending on the size and the dataset. And here we can download the data. This will open our folders, local folders, and you can choose to download the data wherever you want. What I recommend if you have many results or if you have many requests to make is to use our HDI API. The HDI API allows you with a few commands to download all the results from a request in just one line. So you just have to put the directory where you want to download data, and this will download the more than 50 results at one time. So keep in mind that you have this solution. If you want to get more information about the HDA and how to use it, you can go to our help center that you can find at the homepage by clicking on support and then go to help center. From there, you can, for example, type HDA, and then you will see how to use the HDA in Python, in R, or with curls. If you have questions or issues, you can contact us with the widget at the bottom right on WEkEO. By clicking on it, you will have access to this widget and then click on messages, and you can ask us a question like this. First, you will talk to Neo, our AI agent. Neo have a lot of knowledge, but if you have a specific question or if Neo don't succeed to answer your question, you can ask him uh, to talk to a person, and this will redirect the conversation to us, the WEkEO user support, and we will be glad to answer your question. So thank you for your attention, and if you have any question, don't hesitate.
Thank you very much, Alexandre, for your presentation. So
Thank you.
we will move on to some question.
Mhm.
So actually for now on the WEkEO viewer, we don't have, oh yes, we have the first one here
Mhm.
about if AGB data is available.
Um,
I'm not sure what AGB is. I don't know if you know.
yeah, me too. No,
Okay, so
actually, I don't know, but yeah, like I said, don't hesitate to ask the question via the widget, and right after the webinar, we'll check
oh,
this.
so on the chat we have people saying above ground biomass.
Okay.
Okay, thanks. Thanks.
Yeah. So yeah, maybe you can search in the search bar like I show um, some keywords and you will find the dataset. But now I can't tell you.
Okay. Yeah, so I guess you have to look at the catalog because
Yeah.
we don't know it by heart.
Yeah.
Okay, so this question about if we need to have some knowledge of Python or other programming language to access data.
Um, we made the IP the most friendly possible. We have my colleagues will show you the WEkEO Jupyter Hub, where all the environments and package are installed. So this allows you to use the HDA the easiest way. And our article is well detailed, so you will have to learn just 2 or 3 commands to log in and download. And I think you don't need to have some programming language, but I recommend Python if it's the first time.
Okay. So next question, can you upload a shapefile to be used as AOI, or is it just the rectangle option we saw in the example?
Yeah, for the moment, we only have this rectangle option, the bounding box, that can be used. We don't have the possibility to use shapefile. If you have some common knowledge to Python, you can use Xarray to subset your data, but that's not possible in the viewer.
Okay. So this one question about either a DEM or SRT aim high resolution available dataset of the provided data. So I guess we also need to look at the catalog to know
Yeah,
that. I
same
don't know,
as
maybe
before.
yeah.
Yeah.
Okay. Yeah, you can check by keyword on the research bar to
Mhm,
find everything.
mhm.
What is the utility of the job tab just beside layers?
Yeah. So the jobs tab is where you can find all the requests you have made. You have an historic of the previous jobs you made. And if you want to come back later to download your data, you will see all the jobs you made. And once you request your data, you need to go to the jobs tab to see the request. And yeah, you have the folder icon under your request you made to see all the results and order them to just after download them.
Okay. Only visualization data is available on this, or any tabular data also available?
Um, we have some dataset that cannot be displayed on the map. So I think you will have some data that can be downloaded with a CSV format. So I think your question is yeah, some data are not can be displayed on the map. So yeah, some of them can be tabular data.
Okay. Okay. So concerning the limitation of the API request per day or per
Yeah,
account, do we have some?
yeah. Good question. We have a limitation of 100 requests per hour. There is no limitation by day, except for some datasets. If I'm not mistaken, it's the CMWF dataset. This is an issue. Uh, uh, we are dealing with our teams to increase uh, this limitation. But yeah, if you encounter some limitation, uh, we can you can contact us and we'll see in details which limitation you are encountering and if it's normal or not.
Okay. So we also have some question about the coverage. So,
Mhm.
for example, if my area of interest is in a remote area, can I still find data on Copernicus?
Mm, I'm not sure if I don't understand the remote area, but we have some global datasets that cover the world. Um, there is not only European datasets, so you can find data wherever you want, depending on what you are searching.
Exactly. So I guess it's also almost the same of this question about data available around the globe. So you
Yeah,
can find, yeah.
yeah. You can
Uh,
search with tags the area on the left
yeah.
in the catalog. Yeah.
Yeah. So this question about what is the format of the data. So it's usually NetCDF files, if I'm not
Yeah,
mistaken.
Yeah, but you have it's depending on the data set. Some providers are uh, giving data in zip file. Uh, I don't remember what we have. We have, like I said, the CSV format from specific data sets. And for some of them, you can choose the format in the subset uh, on the viewer on the
Okay.
subset layer.
Okay. This question about if the data sets can be used in other viewers with WMS or WMTS calls.
Yeah, I don't
Yeah.
show it in my presentation because our thinking is what more it's for few people's, but below the add to map in the detail window from a dataset, you have just below WMS/WMTS button where you can find the link of the dataset. Um, yeah, you can contact me if you don't find it, and I will show you. But yeah, you have this.
Okay. Okay, so good to know. Hop. Okay, one question about where can we see, sorry, more information about the data processing and algorithm, if possible, used in the analysis.
Mm, yeah, you have. I will show you because I don't. Let me share my screen. Just. Can I? Yeah. Just I still use the share. You can access the Jupyter catalog where you can find many notebooks, and for some of them, you will see how they manipulate the data to for specific use cases. Um, yeah, you have like previously filters. I don't know for what you want to study, but yeah, you have notebooks that manipulates data. So in the Jupyter catalog in the homepage. Hop,
Okay.
I let you the screen.
Okay. Okay, thanks a lot. Hop. So, a few more questions. Uh, no.
Hmm.
Hop. Wait. Uh, can we go back to the screen share of the Q&A, please? Okay, so yeah, next question is about can we do geoprocessing and analysis inside the platform, or is it just for dataset viewer and dataset acquisition only?
Um, mm, Geoprocessing. I don't think from what I show you in the viewer we can. Um, if you want to manipulate data, I recommend to use a language like Python. But internally on WEkEO, we don't have tools to manipulate. We have
Yeah, just
packages in our help center that helps you to manipulate, but internally we don't have something.
okay. Yeah, just to see the data. So
Yeah,
I'm sorry, I think we lost the screen sharing of the Q&A,
yeah,
but yeah,
I
I
still
guess I
it.
will take my time to read them so you can understand them.
Mhm.
So, this question about if it is possible to do processing on the bands after the download.
The bends.
Yeah, bands like bands, BANDS. Maybe the
Mm, now I don't know.
no, no, okay, yeah. So I will put the question aside and we will try
Yeah.
to
Okay.
come with an answer on the post event report. Okay,
Ah, thank you.
so thanks. Can all datasets be used to different software like ArcGIS Pro? So after that, we have a few GIS presentations, but
Mhm.
maybe Alexandre can already try to answer this one.
I think so. I think it depends on the format of the data. But yeah, why not?
Also, this question about the seafloor and continental shelf. So if we can use WEkEO. So yes, we can use Copernicus Marine data
Yeah.
for this one. So
Mhm.
on WEkEO on or the Copernicus Marine website, obviously, but yeah, you can find data for that.
Mhm. Yeah.
So WEkEO is a platform just to visualize and download the data like other sites. Well, yes.
Yes. We just gather all the providers' data. So yeah, you can find the Copernicus Marine data and CLMS data, everything, but all in one platform, in one viewer, and with a common API, the HDA. So yeah, that's the point.
Okay. Okay. So we will do one last question and then we will move on to the Jupyter presentation.
Mhm.
This one about why is the global NDVA layer in the viewer missing large chunks in some countries? So I don't know which layer is it. I don't know if you know
I think
them.
it's the default layer. Yeah. I can tell you now why. Um, Maybe you can contact me and send me some screenshots why you don't find data. But it's maybe due to the time you choose at the bottom of the viewer. Maybe you can change the date and find data um, in a specific area at a specific time. I know that some dates don't show data at some points. Yeah, but try to change the date at the bottom of the viewer.
Okay. Okay. And so this one will be really the last question.
Yeah.
We also have lots of questions about the Jupyter, QGIS, and R tutorials.
Mhm.
We will keep them on the side for the presentation about the tutorials, and we will come back to them after, don't worry. So this one is about if we can provide a metadata file to associate with the TIFF data. So I don't know if it's planned or...
Uh, that's a good question. Um, we have metadata file in the details of the dataset in the viewer. Also, the HDI have a command to display the metadata. So I don't remember, but I think it's a point metadata, and then you put the name of the dataset ID of the dataset. But yeah, I think if it's that you want, we can provide metadata dataset.
Okay. Okay, great. Thanks. Okay, so we will move on to the Jupyter tutorial. Thanks, Alexandre, for your
Yeah,
presentation
you're
in the
welcome.
Q&A session.
Thank you,
And
everyone.
yeah, so I welcome Alvaro for the Jupyter presentation. And whenever you want, Alvaro, the floor is yours.
Well, hi, good morning. Let me share my screen first of all. Well, in this section, we are going to present an assessment of the impact of wildfires on air quality and in the pollutant emissions. In this session, that is in the context of forest monitoring, we are going to evaluate how the wildfires in the forests can affect the air quality. Well, to access the Python, the Jupyter notebooks contents, here in the web page of the course, you can find this tag where you can access to the web page where are stored the contents of Jupyter notebooks. In this page, you will find three buttons. One of them here in the left, and you will find information about how to get registration in WEkEO services, because you will need to be registered, as you will need the credentials of WEkEO to continue with this tutorial. And also you will get information about how to download this tutorial, the tutorial we are explaining today, and how to download this tutorial and install this tutorial in your computer, so you can get the information of this tutorial. For example, the functions we are developing in the tutorial, you can get that functions and translate to your homework. And in this middle button, you will get the access to the Jupyter Hub, where you can run the tutorial. When you access this button, probably you will be asked to select the server options. Keep in mind that you need to select the machine learning, and this will give you until this Jupyter environment. For example, here we can do this here. For example, here we have the web page of the workshop, and you can access this button to access the contents, and you will be redirected to this Jupyter environment, where you will find these regions in the, well, you can see different folders and this workspace, right? It's important to note that you will need to copy. The first step to run the tutorial is to copy the tutorial into your homework. For example, you can see here I have an example already copied called Training Forest Monitoring 2024 Run. And to have this folder in your homework folder, you will find it inside the folder public WEkEO training. And here you will find the different trainings available for this period. And you will find this Training Forest Monitoring 2024. So to copy this folder inside your home folder, we will open a terminal here. You will need to open a terminal here. And just type cd and enter, just in case you are not in your home directory. And well, you can copy by right click. You can copy the path of this folder and type copy -rv, copy, and paste this text. Yes, I got the path, and just finish the instruction with a dot. This dot is critical, so don't forget to include it. And after that, you push enter, and after that, when you go to your home folder, you will realize that there appear the new copy of the Training Forest Monitoring. Here you can see I have a tutorial already run, so you can enter on the tutorial, and you will find this file, Training Forest Monitoring, INB, and you can double click on it to get access to the tutorial. You can see here you get access to a tutorial in Jupyter format. This Jupyter format contains a mixing of documentation and also code cells. For example, here you can see the part of the documentation of the tutorial where we cover some sections like the introduction, how to access the WEkEO data, how to visualize climatic average values, and how to visualize values average during forest fires, and how to visualize anomaly values during forest fires, right? This is the table of contents and the topics we are we see in this tutorial. And here you can see the introduction with some information about the product that WEkEO products can provide information about wildfires. And some explanation of the data sets we are including in this tutorial. And for example, here you can see there is a cell code. These cell codes are devoted to be run by the user. So to run a cell code, you can select the cell and push this run button up here. As you can see, there is an asterisk, and after that, there appears a number, which is the identification number of the run. And well, this is made because you can also play to include some modifications in this cell code, so you can modify a little bit this tutorial. And as you can see, the tutorial continues presenting the data we are working with. In this tutorial, we are working with we propose to work with two different Copernicus products. We are using the Copernicus atmosphere monitoring service of the global reanalysis, the product of the global reanalysis, the global biomass burning emissions based on fire radiative power. As you can see here, they are actually different products. For example, here, this is a global reanalysis, but this second product doesn't provide direct information of air quality. It provides information of emissions, of pollutant emissions, right? Well, here there is also information about the variables we are using. We are using different variables for both products. For example, as you can see here, for the analysis, we decide to work with variables integrated in the air cone. So we do not need to select a specific level to work. These variables are integrated. And in this case, we are using different variables that are actually fluxes because they are actually emissions due to wildfires. In this tutorial, we are focusing, well, we can back to the presentation. Well, this explanation here gives you how to copy. It's really important how to copy the tutorial in your home folder. And just when you entered the tutorial for first time, it is possible you will be asked to select what kernel do you want to use to run the tutorial. So when you are asked for that, you will need to select the WEkEO lab kernel, just in case you are asked for it. Well, as I said before, we are using two different data sets, this one and this other data set, the data set of the reanalysis data and the data set of fire emissions. And these data sets are in the tutorial downloaded by using the Harmonized Data Access API that was previously explained by Alexander. Alexander gives you the information about how to get the request the request you need to use this API. So here, what we have done in this tutorial is to get one of these requests for one of these products, and we have pasted here the request, right? So you can get the request following the tutorial of Alexander's tutorial, and you can get the request there and paste here and continue working and making the specific analysis, right? Well, as I said before, we are using two different products, the CAMS reanalysis and CAMS emissions. And in this tutorial, we are proposing 2+1 study cases, right? For example, since we want to analyze a specific events of wild forests, we propose to work with two different wildfires in the Iberian Peninsula, occurred in the Iberian Peninsula, in the region of Pedrogao in Portugal, sorry, and the wildfire occurred in Losacio in Spain. This first wildfire occurred in 2016, and the Losacio wildfire occurred in 2022. But we also propose to the student, to everyone, to at the end of the tutorial, we also provide information to the student to translate this tutorial to run a third case, but this case is not focused in the Iberian Peninsula, it's focused in Greece. So we propose to make the same analysis for a region that for a wildfire occurred in the Greek region of Alexandropoli. That wildfire occurred in August 2023. So here we give you the information you need to change the code before. As I said before, you can change the code in the cell codes. So you can change the code before to run the tutorial focusing in the Greece event. And well, here I give you can find in this tutorial, for example, here we are working with the emissions data set. And for example, here we're working also for the Pedrogao air quality computed for the period of the wildfire of Pedrogao. So you can see how the air quality is affected in this region of Portugal and the Iberian Peninsula during this wildfire. But since there is computation of the mean is maybe a bit doesn't give so much information, we go to compute the anomalies of these 4 different pollutants here, and we compute the anomalies. So with this, we have more resolution to see or to evaluate the real impact of the wildfire during this period of the event in Pedrogao. But here, for example, I give you a quick view of the results you can get if you finally change the code to run the tutorial over the Greece region for the Alexandropoli wildfire. You will get these results. Actually, these results are the same maps. For example, here we have the average of air quality for these 4 pollutants in the period of the wildfire of Alexandropoli. And you can see here the area mainly affected by the wildfire here, also in carbon monoxide and nitrogen dioxide. And also you can compute the anomaly of these variables. For example, here having a better view with more resolution or contrast of this event. Well, this is all for this tutorial. I hope you find interesting information on it, and thank you for your attention.
Thank you very much, Alvaro, for your presentation. So it was a really nice presentation. So we have some questions for you. So the first one is about the option. So I read the question. I selected the option other than machine learning when accessing the Jupyter Hub. How do I change it? So I guess the other option is like Earth observation or something.
Yeah, well, the way to change that for me has worked to log out. You can find when you enter in the hub, in the file button, you can, at the end of the list of commands in the file button, at the end you will find a logout option. So you can log out ask it again probably about what server do you want to run. But actually, the machine learning, yeah, but the one is the server you need to select is the machine learning, because if I'm not wrong, in the Earth observations tool, you won't have access to the kernel you need. So well, just log out and log in, but not by closing the window, but logging out by clicking on file and log out.
Okay, thanks. So we have kind of the two same question about, so this one about Jupyter tutorial, how do I accept the downloaded training forest monitoring file in Jupyter Hub? So you have to move it yourself, as you could say, but
How do I accept the downloaded training forest monitoring file?
I think it was downloaded directly on the
Well,
computer and it wants to be made on the Jupyter
yeah,
Hub, yeah.
he wants to download this. Well, we can try to make an exercise in live, but I'm not sure if this is going to work. But if you want, I can share my screen. So, because to do that, you will need to work with the terminal. As we said before, the same terminal, we used it before. So I'll try to, do you want?
I think you can share now.
Yeah, well, as I said before, you can open a terminal. Here you have the folder you want to download. Okay. So you can compress this folder by using the command F. For example, this is a command to compress this tutorial. So you can use tar with these parameters. And here you include the name of the final file you are going to create and the name of the directory you want to download. So you can press enter. And here should appear a target file that you can, by right-clicking, you can download it to your computer. Fast and simple. From my point of view, that's the best way to download information from the Jupyter. We download the folder, okay.
I think you're muted.
Guys, you are muted, I think.
Thanks. Yeah, so yeah, I was saying you can run the tutorial also on your own computer, not necessarily on the Jupyter Hub, if I'm not mistaken.
Yeah, that's the other option in the workshop website. You have options to download the tutorial and run the tutorial in your own computer.
Yeah, okay. This question about, is it possible to compare the CAMS emissions to the wildfire emissions as reported according to the IPCC guidelines? If not, how can we compare them?
Well, this is quite a specific analysis. Yeah, I think it should be possible, but this seems to be a very specific analysis. But what is sure, you have the access to the TAMS emissions, and I think you should have access to the emissions reported by the IPCC.
Yes,
And
I think They also
Well,
explain.
the way to compare this is by using Python analysis clearly, but I don't know what is the format of IPCC data,
Yeah.
etc. So you can do it for sure, but well,
Yeah, maybe also in the IPCC report and guidelines, they put the papers reference in it. And if you look at the papers, you can find exactly how they did their analysis, or something like that, perhaps. I'm not sure. I guess so, but. Okay. So this one is about can I use my pre-installed in my laptop notebook version? So I don't know for these exercises. I don't know if the number of the version is the Jupyter version or the laptop version. I don't know if you know by heart the version of notebook, but
me neither, but for
it's
sure,
okay.
what you are going to need for this tutorial is a Jupyter environment with the libraries we use in this tutorial. In this tutorial, we are using not very specific libraries, but maybe the most specific library we are using. Well, we are using NumPy, XRI, Matplotlib, and Cartopy as libraries for data analysis and plotting that are very common libraries actually in Python, in the world of Python. But for downloading data, you will need to install the HDA client. And well, in the help page of WEkEO and the Copernicus data, you will find information about how to download, how to install that API in your Python environment. Alexander, in his presentation, just explained it a little bit how to access the Help Center, asking for information about how to install HCDA. So this is the way you can access there. But well, I think for the version, probably is not a problem. I'm pretty sure, unless this version is very, very old version, that I don't think it's the case. The version of Jupyter won't be surely a problem. The problem or the question to install the Jupyter notebook in your own computer would be surely the creation of an environment that contains the libraries you are using.
Okay, thanks a lot. So this one question is about could we access the Jupyter Hub in the future, even after today's workshop, as long as we have the WEkEO account? So normally you should be able to have access to the Jupyter Hub after the day of the event. I'm not sure for WEkEO, maybe there is a time limit like for the Copernicus Marine one. I don't know if you know that, Alvaro.
Well, I don't know the politics in WEkEO about this, but I think, for example, in navigating through the WEkEO in the public folder in WEkEO, you can see two different trainings available in that public and WEkEO training folder. You can find the training for forest monitoring, that is a training for today's training, but you can also get access to the training vegetation 2023. That I think it's there since 2023. So well, it's probably the account of WEkEO is not going to be removed. I think your account of WEkEO is going to be there for you, for your use. And actually you have here in WEkEO a nice little laboratory where you can experiment with WEkEO data.
Okay, thanks. So yeah, I have the user support on the other side telling me that normally you can have full access to the Jupyter Hub even after the event, but there are maximum download authorized on it. So yeah, you might find yourself stuck with the download. Okay, so we had also this issue in my experiment with Python notebook yesterday. It failed on the HDA client search catalog step with 50 errors. Can I contact someone after the meeting for help? So which step? So HDA for the download of the data, if I'm not mistaken.
Yeah, well, surely you can get access in the WEkEO support in the WEkEO page, web page, the main WEkEO page. This is wekeo.eu. You will find a tab to get access to the support web page where you can go to the help center, and also you have a little button in the support web page. Get contact with the support team, so you will get information about it. But this tutorial has been tested, so I don't know.
Yeah, maybe it's because of the maintenance we had. Maybe it was still having some issue until yesterday. So maybe it could be that the maintenance on the WEkEO website.
There is having some updates these days, and maybe I would that kind of 50 errors. It could be also, I don't know, but make sure that you are copying the tutorial. You are not allowed to run the tutorial inside the public folder. You have to access the folder and copy this tutorial into your home directory. So make sure that you are copying the tutorial in your home directory and running the tutorial inside your home directory.
Okay. Yeah. Yeah. So it's the first step. It's the first step of the tutorial actually. So having it in the right folder. Yeah.
And also selecting the correct server options. Just keep in mind that it's needed to select the machine learning server, because it's also another source of problems and errors.
Okay. Okay. Well, thanks a lot for this question. We will go to take a short break of like 10 minutes. So thanks again, Alvaro, for your presentation and the Q&A. We will see you again for the RStudio tutorial.
Yeah.
And yeah, well, see you everyone in 10 minutes. Okay, welcome back everyone. So I hope you had a nice break and a time to grab a coffee or a tea. We will start again now with the QGIS tutorial by Stefania, also from No System. So Stefania, whenever you want, the floor is yours.
Thank you, Gael, and hello everyone. I'm going to share my screen. Okay. So following the presentations given by my colleagues before, I'll provide you an overview, a general overview of the exercises that have been proposed for this WEkEO for forest monitoring training session. So I will introduce briefly QGIS and WEkEO products that have been used for developing the exercises, and I'll go then giving a short overview of the proposed exercises with some references and conclusions at the end. So the scope of this training session is to provide basically some examples on how we can use geospatial tools like a geographical information system for manipulating, analyzing, and computing some relevant metrics starting from the Copernicus products. And particularly, this training had the main focus on visualizing the products related on land use change and forest monitoring, accessing basically the variables that are supporting in this sense, and providing a very short overview about the potentiality of QGIS in analyzing this kind of geospatial data. But before starting, I would like to recommend you to go in the WEkEO for forest monitoring page, where you have a dedicated section about QGIS with information about the software, how to download it, how to download also some plugins that have been used along the training session, together with a video and a document that summarizes and somehow also explain the main steps for developing the exercises. And stay tuned, because in the incoming days, an updated version of this document will be also available for you all, with more additional details on the ones already provided in the document. Of course, it is also needed to mention the fact that we are using QGIS, that is an open source and free software developed by a wide community. And in this specific training session, I've been used the last version of QGIS, the 3.38. So QGIS offers two possibilities for installing it in standalone mode. So basically downloading the executable from the web page of QGIS, where you have also the access to the long-term release, and also an advanced installation through OSGeo 4W that allows you to simultaneously maintain a different version of QGIS in your laptop. But now let's dive a bit more in our training session. And in particular, this slide summarizes the main upstream data that have been accessed and used throughout this training session. Indeed, Alexander already showed you how to access them from WEkEO. So I basically used 4 products: the Corinne Land Cover, that is made available by the Copernicus Land Monitoring Service, the land surface temperature, as well provided by the Copernicus Land Monitoring Service, and the essential climate variables. Particularly, have been accessed the 2-meter temperature, relative humidity, and total precipitation. They are provided by the Copernicus Climate Change Service, and the normalized difference vegetation index provided by the Copernicus Land Monitoring Service. All these variables are, of course, part of the huge catalog, as you have seen, available in WEkEO, particularly for supporting this kind of analysis and studies about forest monitoring and understanding of the forest ecosystem capacities along the time. So the first exercise that was proposed is related on the Corinne Land Cover. Corin length cover data is provided by WEkEO in GeoPackage format, so I'll keep somehow a link also with the previous questions about the supported formats by QGIS. And this is done basically by adding the GeoPackage file through QGIS after selecting the data manager. Of course, here you have, as a product, the Corin length cover is characterized by many information inside once you download, including metadata that are fundamental for developing the exercises. Indeed, as shown in the technical document, after importing the GeoPackage file into your QGIS environment, you can customize the legend by accessing the properties section in the active layer once selected, and through the legend file that is available in the Corin length cover product, you can basically fulfill the last step of the workflow that embeds the codes of the classes of your Corin length cover, and then you can display it as I show you in the video and in the technical document in your QGIS environment. Of course, we can use QGLS for selecting an area of interest and make some subset, or simply querying the map point by point. And this is what I've explained in the tutorial. So basically, in the area, I selected an area in Spain, the National Park of Cabañeros, that is well monitored, especially because it's one of the most peculiar and critical area because of wildfires. And these kind of tools can be extremely supportive in this sense. Of course, you can use some basic statistics for computing the metrics, as I've done here, by showing the characteristics, the spatial characteristics of the selected area, and particularly for the area covered by the class 3 that is related on forests and vegetation. The second exercise is instead working on the land sea temperature that is provided as netcdf file. In this case, we can access and import the file through the netcdf plugin provided by the Copernicus Marine Service, as I've shown in this slide. And after ingesting it in your QGIS environment, you can display it and manipulate the legend and the symbology as you prefer to improve the user experience for analyzing this kind of product. And of course, QGIS provide also some functionality for computing some arithmetic operations. The example here shows that the land sea temperature is provided in Kelvin. So through the raster calculator, we can convert in Celsius and display it in the map, as I've done here. So again, we can subset the map in a specific region of interest, as I've done in the same bounding box that I was selecting before. And here you have basically the land sea temperature that is focused on the area of the National Park of the Cabañeros. And this is done by basically working with this kind of file that is a raster and performing an extraction by using the mask layer as previously defined. So the red box previously drawn in your map. The third exercise instead focuses on the essential climate variables that are also relevant when you want to monitor the characteristics of your specific region. They are provided by WEkEO in GRIB file, but also, as Alexander said, you can specify how you want to download this kind of files, and in experimental phase, there is also the possibility to download in netcdf. I use the GRIB file to have the opportunity to show that the importing of this file through QGIS is extremely straightforward, because you can add basically it as a layer, as a raster layer. And as soon as you have done this for the 3 climatological fields that I have been accessed, you can display them, in the layer board. Of course, another important aspect that any geospatial analyst would like to do is to extract the information on some specific region. And in QGIS, by typing the keyword world in the panel below, where there are the coordinates of your map, you can display basically the world map layers that I'm showing here in this chart. And after that, you can simply display the 3 fields as I've done in the exercises, and customize the palette, of course, to improve the visualization of these physical fields. Then, as I mentioned before, the world map is extremely useful because we can select any of the area or the region or the country that we are interested to analyze. And by following the workflow that is here represented, so clicking, selecting, and saving what you have selected in a specific layer, you can then obtain, for instance, in this case for Greece, the specific layer where you can compute the metrics related or the average values for the essential climate variables that you have been downloaded. And this is done basically by computing statistics through the processing toolbox zonal statistics function that is available in QGIS. And once done, and of course following the steps that are also described in the technical document, you can finally achieve this kind of output where you can compute the minimum, the maximum, and the mean value, for instance, of the total precipitation, relative humidity, and 2-meter temperature in the Greek country. The last exercise that has been proposed is related on the NDVI, that is important variable, as you know, for characterizing the vegetation coverage in a specific region. And this is provided by WEkEO as an NetCDF file. So again, this can be easily imported by using the Copernicus NetCDF plugin. And as when you do this, of course, every time you import a new file, this is displayed in the QGIS with the default symbology. So then you can act in your in the properties layer of your active layer and set the ranges that here are representative for the NDVI, particularly when the values are -1 is referring to area with water bodies and so on, or snow area, when it is 0 with bare ground, and when it is 1, the region means that is with dense vegetation. And this is an example here of the resulting field as you can display in QGIS. Of course, I mean, when we want to monitor specific events or specific regions, we would like to cross-check and cross-link all the layers that we have right now imported. And this is done basically by exploiting some processing toolboxes that are provided by QGIS. In this way, for instance, choosing sample raster values, so points where I'm interested to extract at once the information from the essential climate variable and the NDVI in these 3 regions, and using the toolbox and particularly the sample raster values, I was able to run in batch process, so in one shoot, all the files and extracting the relevant information, as it is shown at the end when you run, and these steps are described also in the document. You have basically the tables that contains the information of the essential climate variable and the NDVI in the points that have been selected, and by merging them in a single layer, you can display a table that further can be exported and manipulated in other, for instance, in Python or in any other language, if you would like to, or simply interface with your downstream application. So, conclusions, very general, of course, QGIS offers many capacities for analyzing Copernicus products and supports different file format. You have seen that WEkEO offer not only tabular format files, as Alexander was saying, and NetCDF, but also GRIB and GeoPackage. These are pretty easily to import in QGIS. we can perform some mathematics in the rasters, or more in general, in the layers that we are able to ingest in our QGIS by using raster calculator or geoprocessing tools. And this is very useful when you want to calculate metrics or quantify some specific variables in the region of interest. And with zonal statistics, it's also possible to compute average quantities, for instance, for the essential climate variables for monitoring purpose, not only as I briefly show here to you in one specific layer, but you can also try to download a short time series and use the zonal statistics tool for computing the relevant statistics also over time, and then continue your analysis, your spatial analysis with QGIS. So thank you very much for your attention.
Thank you very much, Stefania, for your presentation. So we will move on to the Q&A session. So for now, we have just a few questions for you. So the first one, so we had it at the beginning of the session. Maybe you can have a more detailed answer. Is the data processed in this platform can be used in others such as ArcQGIS and ERDAS Imagine?
I personally don't know ERDAS Imagine what if it is a software or specific product, so I apologize for this. I will detail later on, but surely for the first part of the question, of course, the training, the examples are proposed for QGIS, but they are extremely applicable also for other GIS environments like ArcGIS. So the answer is yes, you can process. Of course, what is going to change is, as expected, the weight of the functions are available, but in principle, the logic and the steps that you need to follow for manipulating this data is pretty equivalent.
Okay, thanks. Thank you. So it's also almost the same question that we have here about Alfred being an ArcGIS Pro user. So is new in the QGIS software. Those all data from QGIS can be used in ArcGIS Pro and vice versa. ArcGIS
yes.
Pro. Yeah, it's also working for the Pro here. Okay.
Yeah,
okay,
yeah, absolutely. Of course, I mean, the principle of any geographical information system is to work with raster and vector layers. So in principle, the commands that are proposed here for QGIS can be ported, could be nice to be reproduced in your ArcGIS environment.
Okay. So this question about how to use QGIS for forest mapping. So kind of what you did in the tutorial.
Yeah, I mean, at least it was a first attempt, or just to maybe a bit concise, but of course, this training is not pretending to give the full overview of the capacity of QGIS, but also of the specific topic that is forest monitoring that is quite important. So my advice is to of course, we go in the WEkEO catalog and search for the variables that are related on any kind of spatial understanding of the distribution of vegetation in your area. I tried to do this basically in this tutorial, keeping the information that to me might be relevant for doing a first assessment of forest mapping and land use, like the core inland cover that contains basically all the information related on the forest mapping with the class 3, as I shown, but of course you can expand and add also other layers, as Alvaro was showing before, about air quality. I mean, the WEkEO is really rich of data, and it depends, of course, on that kind of analysis that you would like to perform.
Yeah, exactly, yes. This question, why do we need to use the NetCDF data since the area another common raster data? Could you explain the advantages using NetCDF format data?
Well, of course, there are also the GeoTIFF is a georeferenced information. It depends. I mean, there are some communities that are working intensively in developing, of course, application based on ingestion of raster data like GeoTIFF, but as well, the community is expanding and taking benefit of the standardization of the NetCDF format that contains also information inside the metadata about the data source, the data origin, the data processing. So it's a matter of opportunities in the kind of analysis that you are performing. Of course, for some specific application, the raster data, the GeoTIFF are quite straightforward, easy to manipulate and to ingest. For other kind of analysis, like the for instance, keeping track of the source of the data, the NetCDF can be supportive as well. So, I mean, there are advantages in using both. It's not indeed WEkEO is providing for some of them, for some of the products, different format because it is the community requesting for that.
Yes, exactly. So yeah. This one question, so about how to access the data. So I couldn't get the data as I missed a related session on the first day. How do we get the data? I managed COWIN, but now the climatology. So all of the data, you access them by the WEkEO viewer, if I'm not mistaken. So it was shown in one of the previous presentation of this morning. You can have access to the replay in about 1 week, but maybe you want to say a few words also to recap everything.
I mean, just to complete your nice explanation, Gael. In the document, I have also reported the dataset name. So for that, you can check which is the and put in the WEkEO search bar the dataset name that is also available in the document, and see for the length, sea temperature, what I have been downloaded. Otherwise, we can support you with more specific information if you still have problems in finding this dataset.
Yeah, the full tutorial is well explained for the downloading. Okay, so this one about a specific plugin. Can the NetCDF plugin be used in the QGIS 3.38 standalone version or just the OCH network installation? Sorry for the pronunciation.
Yes, the answer is yes, in the sense the two ways that you are downloading and installing QGIS standalone or through the network installation gives to you at the end the QGIS software. Then in QGIS software, you can add any kind of plugin through the plugin manager as well the NetCDF. So you can do in both cases. At the end, the plugin is going to support and serve the QGIS software.
Okay. Okay, thanks a lot for the explanation. Oh, sorry. Okay, so I think I have an internet issue, but we will move to the question just under it. I have successfully installed the zip plugin for QGIS that you provided in the course to load NetCDF file. I cannot find it in the toolbar. How to make it appear?
If I'm not wrong, in the toolbar, when you are in the top panel of the QGIS, by doing right-click, you have several options, and you might select the one related on the properties of the toolbar, something like this, and you can find. But I'll search better to give you an answer more specific. There is a way. It's just sometimes it, also depends on the version of QGIS from one to another, since they are doing many an important refurbishment of the code. It might be that simply it's straightforward in one version and not in another. But I'll check in the 3.38 version and I'll let you know.
Okay, thanks. So I will put the question aside for more detail in the post-event report. Okay. The next question, again from Alfred. This platform is very useful since I'm working in GIS world of work. I love WEkEO. Okay, great.
Good.
Is the
We
base
too.
map is the base map of this QGIS updated? How often does the base map update?
In the tutorial, I show you basically a way of importing the base map that is the OpenStreetMap, but you have also the quick mapping plugin that you can choose, and I invite you also to check other training session where I explained that. And basically, it's a plugin that you can, of course, install in your QGIS, and then to perform a search in the network, in internet, with some other providers of base map like Google, NASA, and so on. And in this way, you will always access the most updated version of base map. So there is a plugin, quick map service, something I don't remember now the exact name, but again, I can be more specific if Gael share with me this. I can share with Gael the answer, and she will forward to you. But
Yeah,
it's possible with the plugin, but surely.
Yeah, I will also put the question on the side to not forget about it for the report. We have like three questions, so I would put this one on top, but 3 questions about the QGIS version and the plugin name. So on the full tutorial, on the documentation, if I'm not mistaken, you run several tests with different versions of the QGIS.
Yes, surely with the long-term release that is 3.34 and the last one, the 3.38. Every time we try to test the new version, but of course the compatibility with the plugin, particularly the Siemens NetCDF, is tested every time, and it works. So the answer is yes, it can work also with other version of QGIS. Now, which is the limit of this on the way the QGIS can import this plugin in terms of version, I really don't know. But surely for the last year of releases, yes, it has been tested and the plugin works.
Yeah. Okay. Oh, okay. Sorry. Okay. Yeah. So we invite you to have a look at the documentation Stefania made for the training. Yeah. And one last question before we move on. So it's a more general and open question. Do you have any say on how to use QGIS for climate change monitoring?
Indeed, this is very general and very nice question, because gives the opportunity to say that these kind of tools, together with Jupyter notebooks and other kind of languages, support, of course, the studies and the monitoring on climate change. So, of course, what you could do, as I was mentioning before, is to download more data from WEkEO for a longer period and exploit the capacity of QGIS for subsetting in a region of interest, where, for instance, you would like to analyze the impact of the land change use, and because of droughts, extreme events like droughts that can occur in some specific region and that can have impact in flooding or in other events that consequently can occur. So QGIS helps, of course, in performing geospatial analysis, in realizing maps, in cross-linking layers that can be queried in a very automatic way, and can support also activities related on monitoring by selecting area or points or region or countries or any, but even transects, sections, I mean lines basically that you can draw in your as I show in the video, if I'm not wrong, and you can monitor, because QGIS gives to you the possibility to extract all this information and then compute indicators or derived quantities that might support monitoring I mean, on understanding of the impact on climate change in specific regions through events that might occur.
Okay. Well, very nice answer. So thank you very much.
Thank you for to you and to the audience for the answers, for the questions. Sorry.
Yeah, we have also some unanswered questions, but yeah, as you know, I will put them aside for you to answer later on the post-event report. So thanks again for your presentation and the Q&A session. So now we will go to the last presentation of the day. So the RStudio tutorial. Alvaro, whenever you want, the floor is yours and you can start sharing your screen.
Hi again.
Hi again.
Well, now I am sharing my screen. Well, this presentation is to give a show of the tutorial we are presenting for our studio. And in this studio, we are providing also an assessment of the impact of wildfires on air quality and pollutant emissions. Well, going to the web page of the workshop, up here, like in other cases, you have the tab to access our studio contents. And in this page, you have two different buttons. The first button is devoted to get access to our studio, because this tutorial is presented unlike that in the case of the Python content. This tutorial is presented to be run by users in their own computer. So they need to have installed the IDE we use for this tutorial. For example, you can use RStudio. We propose to use RStudio, which is an open source integrated development environment. So here you have the instructions about how to download this program and install this program. This program contains an interpreter of our programming language, which is the programming language we are using in this tutorial. And also you have the video tutorial where you can get the full information of this tutorial. We run the tutorial in this video and we explain every code line. And also in this page, you have access to the tutorial. Since this tutorial has to be installed in your computer, there is this, you can download a tutorial. In this tutorial, you will find 3 different elements. The first one is a folder called data, where we have already downloaded the data you need for the tutorial. So there is no need of downloading any data for this tutorial. We are going to focus on how to use this data. You can access the tutorial. Well, going to this document, the documentation of the tutorial, you will find that it contains all the information of the tutorial. In this tutorial, we are covering these different sections. First of all, we provide a very short introduction about the topic. As I said before, the topic of this tutorial is an assessment of emissions and air quality impact from forest fires. So we provide some introduction about the forest fires and the pollutants emitted by forest fires. And in the next section, we explain the data sets we are using in the tutorial. And after that, we jump into the sections where we are starting to work with code. First of all, we provide some information about the setup of our environment, because as happens with R, we need to install some libraries. We will explain this later. And after that, we have these different sections where we are working specifically with data. First of all, we are going to explain, or we are explaining how to access the data. The data we are working with are stored in netcdf format. So we are learning how to access this format and how to access the different objects included in this format. And once we are working with this data to provide a visualization of the average climatic values of any variable, actually, it can be to any variable, but in this case will be applied to variables of air quality and emissions, pollutant emissions in the context of wildfires. And after that, we will go into a specific analysis of a specific event by the visualization of the average values of air quality and pollutant emissions during a specific event of a wildfire. And after that, to get more contrast in our results, we will compute the anomaly values of these pollutants during this event, and we will see how to visualize the results with higher contrast. Well, going to the introduction, we do not spend much time on this. We know that forest fires has lots of impacts, socioeconomical impacts in any sense. One of these impacts is the emission of different atmospheric pollutants like carbon monoxide and nitrogen dioxide, carbon dioxide and particulate matter, for example. And well, we are trying to make an analysis focused in the Iberian Peninsula, so we can evaluate the impact of wildfires on the air quality and also the pollutant emissions, right? So in this tutorial, we are proposing to use two different data sets, where both data sets come from the Copernicus Atmosphere Monitoring Service. One of the data sets, one of the products, is the global reanalysis of air quality that gives information of air quality for many different variables. We have selected for this exercise, for this case, these 4 different variables that are integrated in the air column. As you can see here, we are using carbon monoxide, nitrogen dioxide, nitrogen monoxide, and sulfur dioxide. But we are also using a different data set that is provided or is trained from satellite data from teledetection, which is a global biomass burning emissions based on fire radioactive power. And from this product, we are using these 4 different variables. For example, we are using particulate matter, PM2.5. As I said, as here, we give you the information. You need to download the data from the Copernicus data viewer, but as I said before, there is no need on going to download this data from Copernicus, because the data are already included in the tutorial. Well, after that, we start working with our code. As you can see here, in the tutorial, we provide the information of the code. The lines of the code are explained, and also, for example, you can see here we have a cell of code that is one of the first lines of code you will find, that is the loading of the different libraries you are going to use in this tutorial. And as you can see, also we provide links to the documentation of these libraries. So if you need more information about these libraries, you can follow this link to the libraries. And also we are providing also the links to the documentation of these Copernicus products we are using here, right? So going back. the presentation. As I said before, we have this document that gives you all the information you need to follow in this tutorial. This document and also the video tutorial are almost the same, but in different format. And here, once you make a double click on the R studio, will open with this kind of environment that probably is familiar for you if you use this kind of programs. Here you will have a window where you will have the script, and you can run any line of this script by selecting the line and pushing Control Enter. Here you have a console where you can type different R instructions, and here you have another in the bottom right side. You have this window where you will see the different results of what we are plotting in this tutorial. Well, here we have the environment, and as I said before, we are using two different Copernicus products to make the analysis with different variables, but in the same region that, as I said before, is centered in the Iberian Peninsula. So we are selecting this range of latitudes and longitudes and this period of time. Well, this tutorial is presented proposing to analyze two specific wildfire events, sorry. So we are proposing to analyze the Pedro Grau event that occurred in July 2016 and the Los Acio event that occurred in a region called Los Acio in Spain that occurred in August 2022. But well, in this tutorial for these two events, we are computing the average of air quality variables, so we can provide information of the average air quality in the period of the event, so we can analyze how what region were mainly affected. And well, we can also, for example, here we have one of the results that is provided in this tutorial that you will learn how to provide this kind of result. For example, is the average of air quality computed in the period of the wildfire of Pedro Grau, and you will see by these four different pollutants, concentration of pollutants. And since we want to analyze the specific, contribution of the wildfire, we will learn how to compute the anomalies of these mean values. So with this, we are obtaining products that are not referenced in absolute values, like, for example, here, kilograms per cubic meter, square meter, excuse me. But we are using values of average that goes from 0, so that they have negative and positive values, where the 0 is the average of the climatic average. So with this, we are obtaining in red colors the results that goes over the climatic average. So we see in red colors the results that are higher than the mean and lower than the mean in blue colors, like here, for example. With this, we obtain a very clear signal of the region affected by the wildfires. And here we have a result provided by working with the emissions data set. As you can see here, this is the anomaly of the emissions associated to the specific event of Pedro Grau. And we can see here that this product gives a very focused specific region that was affected because this product doesn't provide information of air quality. This product provides information of emissions, so the emissions were concentrated in this specific region. So we can evaluate what emissions we had during this period and where the region that was mainly affected during this period. Here we have another result that we are creating in this tutorial that we are evaluating. For example, here we have the climatic mean of emissions associated to wildfires. Again, we are working with a data set of biomass burning emissions. So we can evaluate for these 4 different pollutants, what regions provide, what regions are more affected by the emissions of wildfires or emissions associated to wildfires. For example, here you can see this region, northwest region of Iberian Peninsula, has the highest impact of wildfires, but there are also impacts in different regions of the Iberian Peninsula. And well, here is extra wall. This result is not given in the tutorial, but if you go to the tutorial of the Python tutorial and you get a data set you download from, as I explained it before, in the Python tutorial, you have also the possibility of downloading data for the region of Greece and analyze the Alexandropoli wildfire occurred in 2023, in August 2023. So you can get the data downloaded from that tutorial and brings this data to this tutorial and produce this analysis for the same analysis for the Greek wildfire. So you will see that the impact of that wildfire in a different region. That is more to demonstrate that this tutorial is very easy to be transported from a region to another region. Yeah, right? Since this product, the product we are using in this tutorial is a global product, you can transport this tutorial to any region in the world. Actually, you can go to analyze the wildfires in any place of the world. Well, this is all for this tutorial. Thank you for your attention. I hope you find interesting information and interesting functions in it.
Thank you very much, Alvaro, for your presentation. So we will move on to the last Q&A session. The first one, the data you are working with has been previously downloaded. How can we work directly with data through the WEkEO API? Is it possible?
Yeah, I saw in the Alexander's presentation that there is a way to work with the HDA AP with R. So at the end, it's the same. You need to install the HDA library in your environment. In the help page, you will find information about how to do that. And since you have the HDA API, you only need to know the request you need. Maybe it's the most obscure part because depending on the data set you want to use or the specific region you want to use, variables, etc. You have a different request. The steps of going to the WEkEO data viewer and creating the request you want and copying the request from the WEkEO data viewer.
Exactly. Thanks a lot for the explanation. So this question is about an issue with the R tutorial. So I received the error message, error in OpenNC file name, could not find function OpenNC. So when Alexander did the review of the tutorials, he hadn't found anything, I think. So do you have an idea from where it could come?
Well, if all the modules were previously installed, the first lines I don't know if the user, the person is talking, all the modules were loaded or installed. There is code lines that are commented in the tutorial that are devoted to install the modules. Maybe when you installed these modules in your computer, there was some kind of error, because what is happening here clearly is that the module open and see that comes from the library devoted to read netcdf files is not working.
Okay. Thanks. So, a more general question: how to carry out real-time monitoring of forest when imagery of area of interest is not available? Well, I think depending on the site, you could do perhaps an interpolation, but I'm not sure if it's like a whole area which is not available.
Well, you should evaluate what is the release frequency of the product you are using. And well, since you have a programming language, it's pretty simple to download to program an automatic download of the data, so you can follow the product. But obviously, you need a product that is provided in the frequency you need in real time.
Yeah, exactly. Thanks a lot. So this one is about some R packages. So I tried to install the packages R natural earth and R natural earth data, but they seem not compatible with current version. Do I need to use the version before? So maybe it's maybe it's an incompatibility problem. I don't know if you know that, because I'm not an expert in RStudio, but
Well, yeah, I didn't know about this incompatibility. Well, maybe we should think on changing these libraries in the.
Yeah.
But actually, well, a fast way to solve this is avoiding to use our natural earth data. This data will give you information of give you information of contour lines of countries and continents, and also borders of continents. We are not using in this tutorial masking of continents, so the only information given by this library is the contour lines. So, well, you can just comment the lines where this library is used, and well, you will receive the results without contour lines of continents. But well, this library should be. You have two ways of action. You can change your R version to a previous version, or you can change our natural earth with other library that will provide you information of coastlines.
okay. Yeah, okay, I see. Yeah. Thanks a lot. So we have then two questions of Ravi. So the first one is about an error occurred when opening CSV file.
Well, we are not using CSV files in this tutorial. We are only using netcdf files.
Yeah,
so...
that was so I'm sorry, Ravi, I don't think we can help you with this question. Maybe if you can give us more detail to the user support, but yeah, for now, sorry. And for your next question is about, again, the NDVI file, if it's also working with RStudio. So if I'm not mistaken, it's a product, so it should work with R also. But yeah, we invite you to try that on your side. Yes.
Well, not sure what NDVI files
I think it's a project. Yeah.
What format, but obviously they should need to find a library that will you that give you access to this kind of data.
Yeah. Okay. Oh, yeah. So check at home. Yeah. One last question for the tutorial for now. Are you considering seasonal variable during analysis of the anomalies, or this could be something to figure out inside the package library?
Yeah, in this analysis, we are not considering the seasonal variability. Well, we could do this analysis, including the seasonal variability, and also we could do the analysis considering the specific means of the period of the wildfires. But in this case, for simplicity, we did decide to consider only annual means for the analysis for the anomalies. But well, there shouldn't be very difficult to compute the seasonal anomalies computed referenced to the multi-means, because, well, as in this tutorial, we are explaining how to compute temporal averages over specific periods. So you only need to change the period for the computation of anomalies. You only need to change the computation of the mean over the specific period you want to compute the anomaly. So you will get an anomaly considering the seasonal variability.
Okay, thanks a lot for the explanation. Okay, so I think it's still, yeah, okay, I still have an issue on my side, so I can hide this question. But for the more general questions, I see about the replays and the certificate of attendance. So sorry, I'm talking a little bit in case some other question arrive on the tutorials, Alvaro. But yeah, so the replays and PDF will be available in the next week. So you will receive an email. So I know some of you had issue with the sound and the video at some point. So the replays will be available. So don't worry about that. You will be able to check some things you need again. We will also have a certificate available for the meeting, so you will receive them after the event. And yeah, we also do lots of other events like that, so don't worry, you will also be made aware of them. Yeah, so we don't have more questions about the air tutorial, so thanks Alvaro for both of your presentation. So I guess we are coming to the end. So yes, thanks to Alexandre and Stefania and Alvaro for their presentation. So I hope for the participants you had an interesting event and that you could learn a little bit more about what the Copernicus WEkEO service offers in terms of data and in terms of information. So yeah, again, about the replays and the presentation and the certificate of attendance, you will have everything. Also, for the unanswered question, we had a lot today, so we are sorry that we didn't have time to answer everything, but as I said, we put them aside to make them available in a post-event report in the same time as the replays, and everyone from the speakers will contribute to answer everything, so do not worry about your question. And yeah, finally, I just want to take a few minutes of your time about the surveys that we had. So some of you might already have seen. So it would be wonderful if we could know what you think about this format of webinar and what you thought of today's session. So we know that the online session for the tutorials are not ideal, but we have lots of participants, so we can go back to face-to-face event. So we tried the best that we can with the Q&A session to answer everyone. But yeah, if you could take a few minutes to answer the survey and let us know what you think. Also about the technical issue you might have had, we will do a checkup with our partners for that. So yeah, thanks again to everyone and have a nice end of day. Goodbye.